All right, everyone, welcome to this week's Advanced Digital, where we are actually going to be talking about T-Splines. And T-Splines is what's traditionally called a subdivision modeler, a short SubD modeler, where you're going to see the website here. It's very commonly used for modeling single surfaces. Well, not necessarily just single surfaces, but for the most part, single surfaces that have varying degrees of complexity in the same surface. So you'll see it commonly used in car design, industrial design. It's very similar to full-blown programs like Maya, where the animation movie industry uses a lot, in particular gaming design, that sort of stuff. And or Modo, which is another very sort of industrial design-oriented modeling program. And they all kind of specialize in creating sort of organic freeform surfaces that you commonly see in car design, industrial design objects like your cups, cell phones, TV remotes, things like that. So in particular, what T-Splines does is it actually kind of subverts a couple of the basic tenets that we've been talking about in terms of Rhino modeling. We've talked about how Rhino surfaces are always rectangular, right? And the sort of number of points in a specific Rhino surface's UV subdivisions are always equal across the surface, right? T-Splines actually is a way of kind of modeling these surfaces that allows for uneven distribution of surface detail. So, this is a comparison of a frog, where a NURBS frog would have somewhere around 11,000 control points, where a T-Splines frog has around, 5,000 or so control points. It allows for local detail, so you're able to actually sort of specify by kind of adding a little bit of more detail, more control surfaces, control detail only where you need it, but not across the whole surface. Whereas in a sort of Rhino NURB surface, you would need to make basically a fairly dense surface with many UV subdivisions, kind of achieve the same thing. And the other big thing that T-Spline does in particular is non-rectangular surfaces with star points, which means that not all the surfaces in T-Splines have to be rectangular in nature like Rhino or like normal NURBS. This here is a star point where you see that these surfaces are kind of chopped up in a way that is almost impossible to model using normal NURBS modeling techniques. So it's very good for, let's say, in some ways for very specific things, as you'll see. However, what comes with it, and generally with most subdivision modeling programs, is that it's more intuitive. It's more of like a sort of push and pull clay modeler, which can be fun, but it's not that precise in terms of dimensions. It's actually a little bit difficult, or can be a little bit harder to get very specific sort of dimensions, and it will take practice. And also there's some quirks with the workflow that you'll have to kind of learn. Now, where to download? Obviously, it's actually a Autodesk product now. Autodesk bought them out a couple of years ago. So if you sign in with your Autodesk student account, if you don't make one, you should be able to get it for free. And it's not under the featured products. You would have to go to the all products section here to find it, and it's right here, T-Splines plugin for Rhino. And if you're signed in, then you can pick a version, T-Splines plugin for Rhino 4. Now, don't be confused by this Rhino 4. It's not for Rhino 4. It's the T-Splines version 4, right? So the 4 is actually for T-Splines. Instead of Windows language, and you pick these, then you can download it. It's educational license. You can install it on 2 computers, blah, blah, blah. Okay, so once you install it, you'll actually get an email from Autodesk giving you the sort of CD key or this serial number and whatnot that you need to input when you install. Okay, so once you install it, you will see this, and this is the example file that I have right here. Week 7 T-Splines example. This is not week 7, but it's okay. So this is the example file I have, but right when you install it, you'll probably only see these two, or maybe something else, I don't know. But these are the sort of two floating docks that kind of pop up automatically. And these all have corner flyouts, which you can kind of get by holding down and then dragging these out, essentially. I kind of just like let the all commands one kind of float here sometimes, just if I want to hunt through. But you also get a T-Splines menu, pull-down menu here, where you'll find most of the, well, pretty much every single command T-Splines. And okay, and the new in version 4, none of these I think we necessarily will use a lot that way. Okay, so these are the only ones. You'll get also this sidebar, and you can kind of switch it to the other side if you want to, dock it wherever you want. So in particular, I have to go through a few things. Your display probably won't look at like this right off the bat. After installing T-Splines, you'll get a tsShiny view style, a new tsShiny view style that makes your objects look very, very shiny with sort of nice reflections, right? Because T-Splines is really meant for modeling organic surfaces, and in that kind of modeling environment, it's important to see kinks and surface continuity. So this is a view style that they provide. But if you're wanting to model in normal shaded, you can still do that as well if you're more used to that. Except that you have to remember to work with this effectively. Go to the display options and turn on your show isocurves for that view option, for that style. For shaded, I've turned isocurves on. If your tsShiny preview isn't showing isocurves as well, turn that on, right? So you see the isocurves. All right. Now I'm going to switch back to tsShiny just so to kind of make it clear that this is a T-Splines sort of model. You'll see essentially because T-Splines is a plugin for Rhino, it kind of adds a layer or a sort of UI over your normal Rhino interface, and actually kind of has its own set of manipulators that has its own sets of even keyboard hotkeys if you choose to turn those on. That's like right here, hotkeys enabled or not, right? And you'll have to get used to kind of switching between. So this is turning the edit mode on and off. Right now this is deactivated, so T-Splines is off, and my normal Rhino commands are active. When I click on the edit mode, for example, and you see this sort of visual display pop up, that means you're in the T-Splines edit mode, and a lot of commands are more associated with T-Splines, basically. But all T-Splines commands start with the TS prefix. So if you type TS, you'll see this whole row up to here. These are all the T-Splines commands that are available. And if you basically escape to kind of get out of T-Splines edit mode. Now, one thing I've always found very helpful if you go to T-Splines options is so there you will get a couple T-Splines display options here. One of them which is hotkeys, which you can kind of set by yourself if you want. But in particular under the here T-Splines UI, I always turn this on, show text viewport HUD. Okay. What that does is that when I have the T-Splines edit mode on, you get this thing here, which kind of explicitly lets me know that the T-Splines edit mode is on, and all what my other sort of states are, whether my hotkeys are enabled, disabled, this sort of stuff. So this is super useful, at least in my opinion. So because these are blue, you can actually click here to turn things on and off as well. So you don't actually have to come over hunt here. you can do this, right? So in this, hotkeys are enabled. One thing to keep in mind is that when hotkeys are enabled like this, all your Rhino commands are disabled. So like I'm trying to type now, nothing really works, right? Unless I had like specific sort of T-Spline hotkeys set up, right? So if you need a Rhino command, then you have to click over here to be able to do any Rhino commands, right? So before you kind of get used to the hotkeys or setting up hotkeys for specific commands, probably just leave this as disabled because this can mess people up. Okay. Starting out, actually just look at, for example, the create panel here. This create panel has a couple things, but the main thing we're actually looking at is here, the primitives to start out. So you'll see, okay, this is a box, and when you create a box, just like in Rhino, you'll see a big difference is that the box is rounded, right? It's not a square box, because tsSplines is kind of expecting you to basically create things that are meant to be modeled with sort of organically, edited organically. So the way things start out is very different. It's like you're kind of starting out with a lump of clay and molding it or sculpting it more than anything else. Now, all of these, as you can probably pretty easily tell, these primitives actually, when you start the sort of the initiation command, you'll see in particular you can specify the number of X and Y faces, which is the number of subdivisions that it has. So when you're starting out, if you know that I need, let's say, a surface with a little bit higher detail than 2 by 2, then you should sort of specify it here. So I'm changing this to 6 by 6. So like basically when I draw it, I automatically get a 6 by 6 sort of grid surface. This is similar to like sort of rebuilding surfaces in Rhino, but just like right off the bat, if you know you're going to do something a little bit more detailed, then this is a good way to start. Now, however, we all know that one of the sort of strong points of tsSplines is to be able to have local control over certain things, over the subdivisions. So we'll eventually get to that. Okay, so these are primitives, and I'm going to switch back to this. So we just talked about the edit mode, how to toggle the HUD display, the T-Spline sort of menu, right? Creating primitives. So let's talk about drag modes and the sort of manipulators. So right now, my manipulator here is set to translate, which basically means move. The mode is set to faces, which usually it should be set to objects generally. You'll see when I click on these and toggle through these options, these icons on the left, these four basically change. So this is the object selection mode. This is face selection mode. So objects would basically allow me to select whole objects. Faces allows me to select individual faces. Edges, so edges, right? Edges. And then vertices, just like a little bit more similar to normal Rhino. If you're used to using the gumball in normal Rhino, then you should be fairly familiar with this sort of manipulator. It works more or less in the same way. So the sort of point editing component is more or less the same. You use the arrows to constrain movement to a certain axis. These sort of little discs constrain movement to that plane. So whether in this case it's the YZ plane, right? So it constrains movement in that plane. And, it's basically kind of one-to-one a copy of the gumball. You can do rotation as well, kind of more or less the same way. Although the rotation for this is kind of for vertex is kind of useless. So let's switch modes to, for example, edges, right? And if I try to select one of these edges and rotate it, then you can kind of see, what rotating an edge would do, right? Or if I try to select one of these guys and move it out, Now you'll see the nice thing about T-Splines is it actually basically it kind of tries to force continuity throughout the surface, regardless of what you do. And so in this space, you'll see the sort of edge actually changes shape even as you're kind of moving it, right? And that's where that sort of organic nature really comes from. So you can manipulate things like that, okay? So the translate is very sort of self-explanatory. Now, if you cycle through, then you'll actually see these options. These are the sort of translate options. So rotate here, which we saw earlier, you can kind of pull on the disks. So if I, let's say, these four and I try to rotate it, I mean, this is not going to get a great result. That's what would happen as we kind of rotate all four of those edges together. So you can rotate in plane, you can rotate out of plane. And, as long as you're kind of like generally careful with what you're doing and you don't try to kind of make any too big drastic changes, you see that the surface continuity is actually maintained quite well for the most part. So let's rotate. The next one is scale, which can be kind of fun. Now the scale, obviously, you kind of mix and match between scale and using like faces or edges and things like that. Edges are probably easier to understand with a scale modifier because, like for example, here, if I made something like this, then these boxes basically represent the direction it will scale. So I can, let's say, for example, scale this whole edge loop in the Z direction. That I can squish it. I can scale it in the X direction to make it wider. Or this box basically scales it uniformly in 2 axes. This is a little bit less noticeable because of in this case because of the aspect ratio. But let's say if I grab that, then you see that profile scales uniformly together. So that's just sort of manipulating edges together and scaling things together. The scale, that's hidden, back to translate. Okay. So that's the sort of manipulator grips, translate, rotate, scale, more or less. The different modes, selection modes, selecting faces, which generally I like to use a little bit more, or selecting objects, the whole objects, selecting edges, which comes in useful from time to time. Okay, now the other thing that's associated with the UI in particular is this right here, the drag mode, which should be set to CPlane, which is your construction plane, the Rhino construction plane, by default. And it basically has to do, change this to vertice. It kind of has to do with this, right? This is oriented with the C-plane. So when you click on it, it can change to view, which is actually, you'll see the arrows are always oriented basically to you or perpendicular to you. Actually, let me force the Rhino gumball off. So you can kind of see this a little bit better. Okay, so this is the T-Splines one. So if I change the view, then this manipulator basically changes so that the movement axes are always oriented towards the camera, or which is your view. If you have a specific view that you want to kind of manipulate these on, so this arrow is going to be always oriented in relationship to my camera view. Not so useful generally. This one though, the UVN, is actually quite useful, especially if you're working with surfaces like this, where its coordinates are oriented based on the surface normal directions. So what the surface normal is at that point is what kind of determines how it does. So, for example, especially for points that are associated with, let's say, curved surfaces, if you kind of pull the blue arrow, that means that it was always kind of moving outwards or sort of perpendicular to the surface normal, right? So in this case, the way I'm kind of editing this by pulling the blue arrow essentially always assures that it's kind of moving outwards, right? Normal to the surface, which is what we call the surface normal. So in this case, it would be up. In this case, in the corner over here, it would be like outwards. Okay. So that's the UVN, which actually uses the sort of local surface coordinates to determine how to move, right? And so you'll see that for edges, it kind of uses the sort of the average, I guess, is what you would call it, the averaged out surface normal. Okay. All right. So UVN world, which is always this way. It usually is the same as your CPlane, unless you have set a different CPlane. Okay, so that's that. TsShiny Display, what I just showed you. The common commands all start with the TS prefix. If you needed to, you can also sort of come here and hunt through some of the different commands if you want to, but they're sort of basically here anyways. These are all the commands. Okay, so let's go through these really quickly. I won't be able to show every single command, but I'm just showing you some of the interesting ones or the ones that kind of find fun to play with. Bridge. So tsBridge, or if you kind of want to hunt through, I don't necessarily remember which icon it's here, bridge. Or you can just like type tsBridge. Okay. Now it asks for basically edge chains to bridge. This is selection mode. If your selection mode is set to edges, actually I don't want that. I want to change my selection mode to faces. I like faces better. So tsBridge. Oops. So selection mode faces. Select face groups, group or groups to bridge. So that is plural, but I'm going to do a one-to-one for now. So you'll see I am going to select this, okay, and then press enter or right click. And then it'll ask me for a second face group, and I'll pick one that's on this side. Then right click. And so you'll see something like this happen. The arrows are pointing the same direction, and just say enter. And you'll see that basically that command forces TSplines to kind of make a tunnel or graft, sort of grow something between the two, which is kind of cool, right? You can really kind of make some really interesting organic shapes this way. So if I change my mode to, let's say, faces, and if for whatever reason, this sort of kind of depends on your modeling sequence. But this can actually work not only between one of faces, but a series of faces. So if I go back to the primitives, and this type of ball is actually a quad ball in particular, because what we call the topology of the surfaces in T-Spline is very important. So you'll see if there's a normal sort of sphere, and as we've been kind of discussing in class, one of the kind of like most annoying things about Rhino surfaces is their UV subdivisions all converge on a polar point, right? And we've seen through several of our case studies that are working with these sort of single surface tessellation structures, that this is always kind of a problem in terms of having a uniform unit. So this is actually not a very easy topology to work with, whereas this, because of the way it's subdivided, is, right? So you'll see in most of these cases, like this is actually a lot easier to work with. Now, what I'm going to try to do, turn my edit mode on, change this to faces, is to run the tsBridge command, and then because it says select face groups, so I can actually 1, 2, 4 select, highlight 4 of these, and then enter, and then select the second group, which would be, let's see, 1, 2, 3, and 4. Okay, then enter, and it will basically run the command on all 4 of these together, right? So you can actually group more than, or bridge more than one object at the same time. Find that a little bit big, so use this. The edges, you can kind of move, and as you just like get a sense, like feel what's happening when you move these things, that like when you're moving the edges, they kind of have a field of influence with the adjoining edges and faces as well. If I want to kind of scale this down a little bit, so I can click on the middle one, kind of scale it uniformly. So this, when I'm using the scale manipulator, clicking on that center box basically kind of scales it up or down uniformly. So do that, right? Or since this was a sort of section ring, the 2D one works just as well. Wider. Okay. Now I'm going to jump to a different command here. Let's see if it's here. The InsertEdge. Okay. So still in edge selection mode, tsInsertEdge. It asks you to select T-Spline edge loop to be duplicated or edge ring to be split. When it says edge ring, it means a whole circle of these, one that kind of goes around the whole thing. So that's why, when selecting, you usually have to try to do something like this. Right click, okay? And then it asks you where you want to put it, or you can actually put a percentage, whatever, and pick a side, this sort of thing, right? So where you add this basically kind of adds a level or an additional data point, right? An additional level of manipulation detail that you can use. So I can basically kind of add one, let's say, right there. And you see how this gets sort of skinnier or creased up. Then, the sort of topology or the way the surface reacts changes again. So I can run the command again, and sort of as I add more sort of these rings, or I insert more of these rings, then you can basically start to gain more and more detail into the surface, or into the sort of overall topology. Okay. Now, its sort of partner command is the next one here called SubdivideFace, where TsSubdivide, right there, SubdivideFace. So it asks you for faces to be subdivided. So, for example, let's find something. Oh, it's okay. Let's just say this. Enter. So you'll see this is the main difference between this and Rhino commands, is that that command or that face could get subdivided or get sort of more control detail, but these adjoining ones don't, right? So I can pick this again and run the command in, and you get subdivide again. Okay? So this, you'll see, makes things kind of manipulatable on a very different level from, let's say, if you were always moving this whole surface, right? And the whole thing moves. Control Z. But if I, for example, let's tsSubdivide face, and I'm trying to kind of get a bit more control detail, and I'm just like repeating the command by selecting a face and then clicking on the space bar, basically, right? I want to get a little bit more control over this smaller specific region, then by essentially subdividing those faces, I can kind of get a bit more local detail and a bit more local control over the surfaces. Now you'll see that because of the sort of notion of like the way these surfaces work, that it will generally kind of affect things about, you know, like sort of 2 squares away. So when I move this one, like you'll see this squares or this surfaces, this patch's geometry gets modified, but this one really doesn't. So it's sort of area of effect, I guess you could kind of see if you're trying to conceptualize this. Its area of effect is roughly, essentially, like generally 2 squares away. So that's, you know, if you're kind of trying to modify a region so that it doesn't, you know, kind of mess things up, then you would want to, you know, kind of going back. Then you would want to kind of subdivide things to a level where there's like sort of two of these smaller squares around you. Face. So to basically kind of like get a region, you know, of these up to the point where, you know, like when I'm manipulating this patch, like it only goes so far and not maybe this one. Well, so see, like once you kind of get enough of separation between, you know, the patch or the sort of face that you want to manipulate and what you don't want to move at all. Then, you know, for example, in this case, like once it gets past this surface, none of this geometry moves. Right? So just like you have to kind of keep that in mind, that in order to be able to get some of this localized detail, you need to subdivide these surfaces to a degree such that the adjoining sort of faces don't get modified. So now, you know, at this point, I can kind of manipulate these to my heart's content without affecting any of this geometry that is around it. Okay, so the last command I'll show in this video is the next one here, merge, tsMerge. And to do that, you will, let's say if you had a, you know, or you can make your own plane. It doesn't really matter. You can take this one. Make your own plane with a certain amount of subdivisions. And I'm going to change to the faces selection method. I'm just actually going to select some of these and delete them. Keep in mind that, like, actually you'll see that when you delete faces, they don't just disappear. They actually do this. Because of the way things are calculated, or if you delete something from the middle, this is what it does. So there's almost this sort of elasticity to the surfaces, especially when you're deleting things like not in a row, but sort of in a corner, right? Because it's trying to maintain a smoothness even in the 90-degree corner. Okay, so that's one of the characteristics. So tsMerge. First edge chain to merge. So let's try this, like 1, 2, 3, 4. These 4 guys. Enter. Edge chain to merge 2. If I only pick these, that edge chain, then you'll see it actually does something like that. So basically attempts as best it can to merge to the other edge chain. Now generally you don't probably, you know, for the most part, you do not want to merge edge chains that have different edge counts or different sort of edge counts like this, because you get things that are just like topology that is a little wonky. Generally, you know, so I'm gonna actually delete guys. Say delete these. Okay. So tsMerge, first edge chain, second edge chain. You know, that's a neat bridge. Okay. So Merge basically kind of allows you to sort of bridge across. It's similar to bridge, except it's the edge version of sort of bridging. So let's say that, enter to, let's say this, enter. Oh, okay. That's kind of what it does. This is not great, sort of twisting, but you can fix that by at the sort of vertices that I'm getting or manipulating that. But like as you can see, it allows it's a little bit more forgiving than Rhino in some ways, although some of the resultant effects you get are fairly particular, and it's sort of more of an intuitive clay modeler. Around with that. The effects of deleting, though, you have to be kind of careful. Can be fairly strange, depending on how you're deleting faces out. They can be interesting, but you'll get some weird stuff sometimes. So, like this is where kind of keeping your T-Splines topology, which is kind of like the way the lines or these isocurves are arranged, clean, is a thing where generally keeping these sort of edge rings or edge loops straight in a row like that is helpful, or it's just like better practice rather than have something that's just like messy and all over the place. Okay, all right, I'll see you guys in the next video.